Hello students, kia ora. Welcome to our first class. So we're gonna start reviewing some information and we're gonna see it here. As you already know, our subject is called Energía y Transformación 1. And the first subject is what it is right there, units of measure and conversions. So we're gonna see some pretty basic theory. Don't worry, you don't need to write it down because this is already on Blackboard. So you just need to pay attention, all right? So here we go. What does energy transformation, or as you already know it, is called physics? What do physics studies? Well, it's pretty simple. We study the interaction of the energy. We're going to have different types of energy. You're going to have a project to show me that you're, well, made some research about this, but pretty much is just every type of energy and the interactions with it. For example, chemistry studies the interactions of the matter. Physics studies the interaction of the energy because we are all energy, but that is another talk for another time. So our very first definition is magnitude. So what is a magnitude? Everything that can be measured. For example, right now you have people right there in the classroom that are, well, kind of tall, right? And others not so much. And please don't point fingers. So how do I know how tall is one person or the other? So I need a magnitude to do that and everything that can be measured. For example, somebody could be really tall and he could be two persons, right? He could be as tall as two persons. So the magnitude that I'm using is a person, a small person. So a huge student or a tall student will be two small students. So that is my magnitude. Right there, I'm using something that can be measured, and everything can be measured. I could say that I'm tall as water bottles, or I'm tall as flowers, or I'm tall as, I don't know, cars, all right? Or maybe I'm not that tall, but here it is. Magnitude is our very first definition that everything that can be measured. So if I have a magnitude, then I can do measurements. Measure is the comparison between magnitudes. How do I know I'm taller than someone? Because I made the comparison. Compared to each other, it is something that we could do to measure stuff. But here's an interesting thing. What happened many, many years ago? How do they measure stuff? Right now we have meter, second, and kilometer, stuff like that. But many years ago, we didn't have that type of thing. So we need a measure unit. A measure unit is a well-known magnitude of perfectly defined value that can be used as reference. So this means it's reproducible. The same meter I'm using here in Pachuca is the same meter that is being used in Paris because we are all using the same unit of measurement. So our measure unit, it is something of a well-known magnitude and a perfectly defined value that can be used as reference. Examples of measures of units of measure, well, we know a lot. We use them every day, but the regular one is just meters for distance. If we are measuring time, we do it with seconds, minutes, hours. Another type of measurement would be kilograms, right? So my units of measure are well-known magnitudes. Magnitude, something that we can measure, of perfectly defined value. So we're talking about the same. So as I was saying, back in, I don't know, 6,000 years ago, 5,000 years ago, how do they measure stuff? How do they build these things? How do they manage to build large pyramids, buildings, whatever, without units of measurement? So if we want to do, for example, a construction, we will need units of measurement. So many years ago, many years ago, we used things like your elbow. We're here. So many years ago, people start using your elbows, right? I'm not a good drawer, but there is. And the distance between your hand and your elbow, that will be the elbow. And people will say like, oh yeah, that pyramid over here, that thing is, I don't know, if I want to build a pyramid, that should be 5,000 elbows and 1,000 elbows, all right? Elbows. Because we use our body as units of measurement. What will be the main issue here? Well, nobody has the same distance of elbow. Somebody will have shorter elbows because they will have shorter arms, and somebody will have, really long arms and therefore really long elbows. So back then, how do they know which elbows they would use? How do they know, oh yeah, we're gonna use my elbow, but then if I die, let's keep my elbow so you can measure the pyramid? No. So that's when the royalty came in. So people like royalty, they start using their units of measurement for measurement units. So, for example, back in Egypt, the king, the pharaoh, will say, all right, this is my arm. And from now on, this is my official elbow. And let's put a stick next to it and put it on the squares. And then people that came to that town will go to measure the elbow. And there you go. That's the first unit of measurement. People measure their elbow and put it on squares and put it on huge public places and to measure stuff. Well, pretty interesting knowledge is that's why there was squares really long ago. So everyone could go to that square and measure your king's elbow and stuff. Pretty much, if you have heard the units of feet, when you're on the airplane and the pilot says like, oh, we're gonna go travel 30,000 feet, whatever. Why are we using feet? That's pretty easy because we're using the last King of England's feet to measure the feet. So, United States is pretty much like, oh yeah, freedom, but guess what? You're using the last King of England's feet to measure your stuff. But then, because we're scientists, we didn't want to stick with feet or elbows or thumbs, which eventually became an inch. So in Paris, French people always messing with, oh, you should do this, you should do that, blah, blah, blah. On Paris, here's the office of the creation of the metric system. In 1795, or as the French will say, in 1795, the foundation of the metric system was taking place. What they did was measure or becoming or developing three basic units, which were the meter. We're going to use meter. They also developed the kilogram weight. This is kilogram weight. And the liter. Why? Because pretty much we were a society that was purchasing and selling stuff. So I need to use the same meter for everything. I need to weigh the same for everything. And I need to have something to pour my milk on it that is the same for every other place in the world. So the metric system was found in this year, and we were using it, and we were trying to everyone to use it. So far, even the United States is not using it because the United States And for example, how do you know how much is a meter? Well, back then they say, all right, the Earth is the one thing that doesn't change, right? So let's measure a meter has a part of a meridian of the globe or the planet. They thought this distance, they thought that, well, because the Earth is always the same size and we're not going to change Earth anywhere soon, this meridian here, this measurement right here, will be the same all the time, all the year, forever and ever and happily ever after. And then they say, all right, let's take one of these and divide it in 1,000,000 pieces. So we're going to take a meridian and we're going to divide it in close. I'm not being specific here, but it's really close. I'm going to divide it in 1,000,000 parts. So there you go. That's how we're going to calculate how much a meter is. But then scientists realize that the Earth changes as the time goes by because tidal forces and the moon and the sun changes the shape of our planet. So they stop using that. So in accordance to that development, they came with these prefixes. What is a prefix? Well, it's right there on the where is here. A prefix is something that you use before. That's why it is pre, which means before. And for that, they invented these prefixes to show a really huge amount of volume or a number. We're pretty much know this one, right? This is like an everyday we use it. Kilo. So kilo is a prefix, which means goes before of something. For example, a meter is something that we know already, right? So a meter measures distance. So a kilometer will be 1 meter times 1,000. So 1 kilometer means 1,000 meters. Pretty much really simple. Also, if I want to go to smaller parts, for example, centi, I could have also a meter, but then I could put the prefix centi. And then I will have centimeter, which means 0.01 meters. This is really important because we use prefixes all the time. Where do we use these prefixes the most? Computing. You have gigabyte, you have terabyte, you have megabyte, and really not so much we use it nowadays because it's really small, kilobyte. We could also have hectometers, decaliters, deci, whatever, and then we use these prefixes to know how much are we multiplying or how much small is something. For example, 1 mega is 1,000,000. 1 giga is 1,000 millions. 1 micro, something, a micrometer means the millionth part, or 1, 2, 3, 4, 5 zeros before something. And then we have every time more and more prefixes because they're trying to measure stuff. And they came up with the metric system because everything is a multiple of 10. Well, this is the initial one. So the metric system prefixes are pretty well known. We're going to use these ones right here. So I'm going to take a moment for you to take a photo of this. So please go ahead. You may take a photo of this, or you could pause the video and then write it down on your notebook. Don't take too long. Just use the very common ones, which is tera, giga, mega, kilo, deci, centi, milli, and that's it. Probably we're going to do some exercises with this. Or you can look at this presentation on Blackboard anytime you want. So After a long year of work in 1795, after building the measurements, the prefixes and stuff, on 1874, or like what the French will say, like 1880, no, 74, the birth of the CGS was taking place, which means centimeter, gram, and second. Because they said, all right, a meter is a huge unit of distance, and some things are really small, so we're going to come up with centimeter, gram, and second. So they also developed how much a second should be. And do you realize we're using 200 years, something like that? We've been using time as a unit of measurement. Yet we haven't used time before. We were just like, I'll see you when the sun is just like over there, and all right, we'll see you there. So centimeter, the gram, and second was born. But then on 1960, which means this is as old as my dad. So we haven't been using the international system that long. That's the meaning of IS, international system. International system because once and for all, we said, all right, no more things weird. We're gonna use one type of unit for everything. And we're looking at you, United States, but you don't care, all right, whatever. So we came up with this international system or these units. This is really important because we're going to use these types of units for all the exercise that we're going to do from now on. M is for the unit of distance, which means meter. Kilogram, it is for mass. I'm going to write it here, mass. Not weight. Weight is something different. Mass. And this is reading kilogram. Like Instagram, kilogram, whatever. Second, we're going to use it for time. Second. A, it is for current. You know, when you light up a bulb or when you put your computer or you connect your cell phone, you use the current. And this is with, I'm going to write here, current. In Spanish is corriente o intensidad de corriente. A is for ampere, which is the last name of the person that came up with it. Mole, you have heard this before. Mole is for also mass, but mass for chemical stuff, things that are really, really, really small. So you have mole, which is the same. And we have these two that I saved just because I want you to remember this for the eternity. Well, as far as you live, which is a lot. So we have Kelvin and Candela. Kelvin, it is a unit of temperature. And Candela is a unit of light. This is Candela, and this is Kelvin. So, you know, when people doesn't have a high school, they tend to do and talk nonsense. Because the measurement for the international system for temperature is Kelvin, and the measurement for light, the amount of light that you have in the classroom, it is called candela. So, for example, you know, when you're on the, I don't know, Prime or whatever, or La Liber, wherever you're going, well, not going because probably you're underage, and you hear something like, yeah, dale candela, well, you need to stop everything. And you need to say to this person like, you really need to go to high school because that's nonsense. For example, here's a pretty good example. I'm gonna turn the audio. So, you need to stop that dude right there, like, whoa, 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 stop saying nonsense. If you want to say like, yeah, yeah, Dale Candela, no, you should change it to Dale Kelvin, right there. You should say Dale Kelvin. And then we can talk because you're a really well, person that understands everything. So no more Dale Candela. This is light. This is Dale Kelvin. So your high school students, from now on that makes nonsense. So I hope you're talking right. All right, good. So in 1960, the international system was born with the units that you saw. But then we need more prefixes. We need a lot, like a lot of prefixes, because every time we were discovering new stuff and more distance and more units. And then we saw the stuff that were really, 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 really small. So we need to come up with new prefixes. So here they are, all the prefixes that exist or are recognized by the international system. On the left, you can see where they were come up with: 1991, 1975, 1960, 1795, which is the one that we already talked about, 1964. So we haven't been using this that long. But here's an interesting thing. You don't need to know all of this. The only thing that you need to know is this part right here. For example, giga, in the short scale, it is a billion, but in the long scale is 1,000 millions. You know, who should or who uses the short scale and who uses the long scale? Guess what? United States uses the long scale. And this is, people that make sense, the rest of the world. So there you go. You have billion when you're talking to giga, but then you have the United States because, oh yeah, no. This should be the units of measurement, and there you go. So we have to split it in two because United States keep using whatever they want as a unit of measurement. So in Mexico, 1 giga, we're talking about a billion. But in the United States, we're talking about 1,000 millions, which is not that much. But then tera, that should be a trillion. But then United States is like, oh yeah, I'm billionaire. Well, yeah, no, you're not. You're 1,000 millionaire, not billionaire, because this should be the real units of measurement. All right? So, for just this one time, do you remember Enrique Peña Nieto? I hope you do. For this just one time, this guy was right.
Gente. Los intercambios comerciales de los tres países superan 1.000.000 de millones de dólares al año. 1 billón en español, 1 trillón en inglés. Contamos con el impulso de nuestros emprendedores, 1.000.000 de millones de dólares al año. 1 billón en español, 1 trillón en inglés. Contamos con el impulso.
So guess what? This is the one time that Enrique Peña Nieto was right. He was trying to make the difference between billion in the short scale and billion on the long scale, but, well, pretty much he was just not having the fame that, well, everybody thought, and then he was just like messing it up again for the millionth part, right? All right, so whatever. So we need to come up with the scientific notation because we're working with a lot of numbers, sometimes a lot of zeros. So on the scientific notation, you can write something different. For example, I'm gonna do a zoom right here. The scientific notation, this is one of the activities that you should be doing after the exercise of conversions. But I'm gonna be just a quick theory right here. Scientific notation is something that can be written as power, not using your calculator, like times 10, whatever, you need to learn that this is scientific notation. So all this number right here can be written as 1.56234 times 10 to the 29. How do I know that? How do I make that change? How do I know I'm doing this part right? Well, it's pretty easy. We're going to do this part here. It's not that I move the decimal point. That makes nonsense. That's how they talk, somebody that says Candela instead of Kelvin, all right? We're going to do this. We're going to start counting. If I want to put my point right here, I'm going to count how much, if I want to put the point right here, I'm going to count how much significant ciphers do I have. And I will start counting, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, da, 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 da. And then I came up with 29. So every time I'm moving something, or I'm trying to write it really, really small, I'm going to count the positions of it. All right, you don't believe me? Let's do this. This is 3, 6. Oh, wait. We're here. Yeah, there's 9. Then, what else? All right, good. 12, 15, 18. What else? All right, good. 21, 24, good. 27, and guess what? This is the 28, and this is the 29. So, which means if I'm writing positive, because you see this is positive, if I'm writing positive numbers or positive powers, I'm going to count the position that is after the decimal point. So I'm counting the positions. Not I'm going to move the decimal point, because you're going to have something wrong when there's the negative or the things that are really, really small. So when it's positive, it's really simple. I count as much positions as there is. But then, I'm going to go back. But then we have this, right? And this, I'm going to put it more, there it is. And here I have something that is really, really, really small, right? This is the mass of an electron. So all of this cipher could be written as that one. How do I know? Well, I need to learn that if I'm writing things that are really small, I'm going to write a minus on the power. And this is going to be the position of this number. You don't believe me? Let's count it. This 9 right here is on the 31st position. Let's count it. 3, 6, 9. What else? Good. 12. What else? 15, 18, 21, 24, 27, 30. And guess what? My 9 is on the 31st position. So every time I'm doing negative things, the negative is telling me where the first cipher is. So the 9 is on the 31st. Or could I also move the 10? The 0, sorry. 0 is on the 31, 32, 33rd position. This one right here. So I could write everything as times 10 to the minus 33. So there you go. That's scientific notation. That's how you're going to research, or you're going to do a collaborative work to solve that one, all right? You could check this thing again later, or you can review it whenever you want it. But then the one thing that I'm really interested in telling you about is this. So how would I know how much bytes are in a terabyte? So this is the subject that you're going to do work on it. It's called conversions. Conversions. Because I'm going to transform 1 terabyte into bytes. How do I know that? Well, I just need to check my prefixes. So 1 tera means 1 trillion, or 1 million of millions, right? Which is a trillion. So that's pretty simple. So no need for this. I don't need to do any other operation. But then I have this one. This is interesting. How many kilometers are in 40 times 10 to the 3 meters? So how much is this? 40, and then 3 more zeros. 1, 2, 3. So how many kilometers are this? I want to turn into kilometers. Oh, let's do this better. Kilometers. So 40,000 meters into kilometers. How do I know that? Well, I need the conversion equivalence. So I go back to my prefixes if I have to, and then I remember that a kilo is 1,000. So here's what I need. 1 kilometer equals to 1,000 meters. Pretty much you're doing on your head, you're doing like, oh yeah, there's 40 kilometers. How do I do that? How do I learn how to do that no matter what are the units? Well, pretty simple. I start with 40,000 meters, kilometers. This is my first step. What do I want? Number two, let's put it here. Number two, what is the equivalence? And step number three, let's do the operations. For example, 40,000 meters, I'm gonna multiply it by something. That something is because I want to get rid of meters. If I want to get rid of something, I just need to divide by it. For example, 40,000 times whatever divided by meters, and then the meters will be gone. All right? Let's do it again, but with another example. For example, if I have 1/4 that multiplies 4, what is the answer? It's 1. Why? Because if I'm multiplying times 1 and then I'm dividing it by 4, by 4, this 4 right here is get rid with this 4 right here. How do I get rid of that? Well, if the 4 was up, I need to divide by 4. So it's pretty much the same here. Meter right here, and I want to get rid of meters. I'm going to put meters below. What do I want? I want kilometers above. And I turn back to my equivalence, and then I found out that 1 kilometer means 1,000 meters. The 1 was here, the 1,000 was here. How do I solve this? Well, 40,000 times 1 divided by 1,000. And this is going to give me 40. 40 what? If I get rid of meters, I'm going to get kilometers. All right? So it's pretty simple. I just need to pay attention to these 3 steps. 1, what do I want? 2, what is the equivalence? 3, the operation. 4, well, the result will be the answer of that. So, pretty simple. Let's do it again, but with another example. It's just, well, no, let's leave it there, and I'm going to go this way. So let's erase our royalty. And then let's assume that I want to change, let's see, I got it. I want to change 5 feet. I want to know how much meters are they. So this is what I want. Number 2, I need to know that 1 feet equals to 30.48 centimeters. Very simple. You could find this everywhere. And don't worry, I'm going to give you this equivalence for the exam, so don't worry. Everything that you need, you're going to have it. So, step 1, I want to turn feet into meters. Step 2, I know that 1 feet equals to 30.48 centimeters. Then number 3, I just need to do the conversion. I have 5 feet. Let's do it bigger. I have 5 feet. Then I'm going to multiply it by something. Feet is on the upper part, or is above everything. So I want to get rid of feet. So I want to put feet below. And I want to put meters up. But my conversion type says centimeters. So first I need to turn it into centimeters. So 5 feet, if I'm going to divide it by feet, I'm going to get rid of feet. My equivalent says 1 feet is equals to 30.48 centimeters. I'm going to get rid of feet, and I'm going to turn in 5 times 30.48. I hope you brought a calculator because you're going to need it. So 5 times 30.48 is 152.4 centimeters. But I want meters, so I'm not done yet. I want to turn 152.4 centimeters. I want to turn it into meters. If I want to turn it into meters, I need centimeters below. So right now, I know, because I already know, it's pretty common knowledge, that 1 meter has 100 centimeters. If I have doubt about that, then I turn into my centimeters. There it is, which means it's the tenth. 0.01, that will be 1 centimeter, but in 1 meter you have 100 centimeters. All right? So 1 meter, 100 centimeters. So how do I do this? 152.4, I'm going to multiply times 1, and then I'm going to divide it by 100. So this is 1.524 meters. So there you go. 5 feet equals to 105.24 meters. And that's my answer. I just forgot to write here is 5. How do I get that? 5 times 30.48 divided by 1. And this is how you get this. All right? So there you go. That's the answer. Let's keep doing more exercises. Where were we? Here. The last one says, what is the equivalent in meters of 5 times 10 to the minus 3 millimeters? So this is kind of interesting. First, because I need to turn this into a regular number. So I know there's a 5 right there. But where does the 5 is? It is on the third position after the decimal point. So I'm going to start counting. 0.1, 2, third position. So 0.005 millimeters, I want to turn them into meters. This is what I want. Number 2, I need to know the equivalence. 1 meter has millimeters, means 1,000. So 1 meter has 1,000 millimeters. Step number 3, 0.005 millimeters times, if I want to get rid of millimeters, I'm going to put millimeters below. And I want meters. According to my equivalence, 1 meter divided by 1,000 millimeters. So how do I make the calculation? 0.005 times 1 divided by 1,000. And this is going to get, or I'm going to get 0.005 divided by, well, multiplied by 1, which is the same, divided by 1,000. Or 0.005 divided by 1, 2, 3, 4. There it is. 0.1, 2, 3, 4, 5, 6. So This is the same as 5 times 10 to the minus 6 meters. Any of those two is the same, all right? So let's do one more. And in this case, we're going to check what you're doing or what you're going to do on your assignment for today. Here it is. For example, this is, I'm going to do just one, all right? But you're going to have to do this individually. For example, 12 kilograms, 2 pounds. And I have that 1 pound are 454 grams. And if I want kilograms, I just need to remember that 1 kilogram is 1,000 grams. I'm going to write it here just for you to remember. Just need to remember because 1 kilogram, you know this already. Kilo is means 1,000. 1,000 grams. There you go. So now you know how to make the conversion to all of it. But what I'm going to work with is this one right here. This one, when you have a combined unit of measurement. Let's do this. We're going to work with this one right here. And here it is. We're going to work with this one. How do I turn 10 kilometers per hour to miles per hour? It's pretty much the same. I just need to learn that doesn't change, right? Let's check it out. I need the conversion. So this is what I want. What is the conversion unit? That 1 kilometer equals to, sorry. It's 1 mile because this is 1 mile equals to 1.609 kilometers. So let's do it. 10 kilometers per hour. I'm going to write it different so you can see that here. Kilometers per hour. And I want to get rid of what? Kilometers, right? So kilometers is going to be below. And I want miles, so I'm going to write miles up. According to my unit of conversion, 1 mile equals to 1.609 kilometers. So 10 kilometers per hour is going to be 10 times 1 divided by 1.609. So the answer is 10 times 1 divided by 1.609. And here's the answer. 10 divided by 1.609. 6.22. 6.22 miles, because I got rid of kilometers, miles. But then I just got remain hours. So there you go. Pretty simple, all right? Don't get confused with the conversion, with the combined units. It's okay. On Monday, we're gonna review how to do the kilometers per hour to now meters per second, which is a double combination, a double conversion. So, but don't worry, you're pretty much thinking right now, how do you solve that one? All right, so there you go. You have a bunch of exercises that you will have to do individually. Don't forget to write your name, please. It's going to be delivered by the end of the class, so you have plenty of time to do this. All right? And for last, you're going to have to do the measurement units and Earth research. So you have 2 different pieces of paper. And in teams of, we're going to do 3. And since we are we're 25 in the classroom, that should be 8 teams, but only 1 must be for members. So you have to start working on this, and then you will have to deliver it by the next Tuesday. So far you have your exercises. These again, these are individually. I'm going to write here individually. Oh, whoa, it's not right. Why? Oh, not right. I don't know why. So this one is individually. And this one right here, we'll have to do it in teams of 3 people, 3 persons. There you go, 3. All right. Here you need to do a little research. Also, you have to practice what I just told you right here. And over here is just a pretty simple research. All right. So there you go. You have work to do. And I hope you had fun watching this video, because I know I had fun making it. So see you next time, and please behave. Bye.